And also, in addition to the capillary action, the sun also enhances this cohesion adhesion. How? The sun do something called transpiration, meaning that the heat of the sun will evaporate water from the leaf surface. When water evaporate from the leaf surface, what happens? It will help to pull water from the leaf, from the leaf, and then you also have to pull water from the stem. It will have to pull water from the leaf and from the stem, and eventually pull the water from the root. So evaporation of water helps the transportation of water from the root all the way to the tree top to the leaves. So in other words, there are two forces that helps the tree to transport water from the leaf to the leaves on the tree top. One is the cohesion adhesion, the other one is transpiration. Now let's go to the third properties of water, resistance to temperature change. So how come water resists temperature change? It's mainly due to the hydrogen bond again. As you can imagine, if we heat, let's say, liquid water, what will happen? Water will each water molecule will gain energy, and then they will move faster and faster. Until when? Until water molecules detach from each other to form water vapor. So how do they stick to each other, and what kind of force water molecules need to overcome so that they can detach each other to form water vapor? That is the hydrogen bond. So hydrogen bond is the one that so-called resist the change of the state. As we learned about in previous slides, water has solid state, ice, liquid state, water, and then gaseous state, water vapor. And hydrogen bond is the one that hold water molecule together to resist the changes from one state to another state. Water has something called high specific heat. If you have taken physics, and if you still remember your physics, then high specific heat meaning that it takes a lot of energy to change the temperature of water. High specific heat meaning the water require a lot of energy to change the temperature. The reason is that water form each water molecule can form 3 hydrogen bonds. Because each water molecule can form 3 hydrogen bonds, it takes a lot of energy to change the state or even just to elevate the temperature of water. And water has something called high heat of vaporization, meaning that heat of vaporization means that it's the energy required to vaporize water, to boil water. Why? Because as I mentioned, because for water molecule forms 3 hydrogen bonds with 3 different water molecules. Because of that, it takes a lot of energy to pull water molecule apart from each other. Therefore, it takes a lot of energy to boil water into water vapor. And then last but not least, water also has a high heat of fusion. Heat of fusion meaning that it takes a lot of energy. It takes a lot of energy away in order to freeze water, to make water, to form ice from liquid water. Heat of fusion meaning that you need to take away a lot of energy in order to form ice. So what does it mean? It means that water form a stable environment for, I would not say aquatic animal, I would say for all living organism instead of just aquatic animal. For all living organism. For example, as we know that human body is made up of approximately 60% of the water. So 60% of our body is water. Why? It helps to maintain the temperature of our body. It also helps to maintain a constant environment in our body. So what do we call it? We call it homeostasis. So water plays a role to maintain homeostasis in our body. Another example is that, have you ever thought about why the housing price along the beach, they are higher, they're more expensive than housing price, let's say, in the inland? I asked this question to my students before in my previous Bio 3 classes. Some of them give me the answer that, because it is a nice view on the beach. Well, yes, the view is nice. And then I explained to them why. Because water has a high specific heat. In other words, it is difficult to make water to change temperature. It is difficult to make water to change temperature. You have to supply a lot of energy in order to change the temperature of water. So if you live in the beach area where a lot of water next to you, then the temperature changes in the beach city will be relatively minimal, or in other words, the temperature along the beach city will be very stable. When it is stable, then it is pleasant to live there. On the other hand, if you live in inland empire that is far away from water, far away from beaches, so what happens is that the temperature changes can be a lot. It's like at nighttime it will be freezing, in daytime it can be very hot. It is nothing will help to stabilize the changes of the temperature. That's why housing price along the beaches, they are very high. They are relatively higher than the housing price in the inland because of the high specific heat of water. So this picture shows you that how much energy we need to supply to water in order to change the state from solid to liquid, from liquid to solid, and vice versa. For example, if we want to melt ice, you need to supply 80 calories so that ice will become liquid water. And then from liquid water, you need to supply 600 calories. Remember from previous slides, we said that water has a high heat of vaporization. That's the reason it takes 600 calories to evaporate water into water vapor. So if you go to the right hand side, it is the heat absorb. Heat absorb meaning that we have to supply energy. For heat release, meaning that we have to take away the energy. So remember the direction of energy. From solid to liquid, and from liquid to gas, we have to supply energy. From gas to liquid, water, from water vapor to water, from water to ice, we have to take away, remove. We have to remove energy. So remember the properties here. Water has high heat capacity. We already explained that. In here, we want to explain to you that I want to give you the definition of calorie here. Calorie is the amount of energy needed to raise the temperature of 1 gram of water for 1 degree Celsius. This is the definition of calorie. If you take my physiology, I will also repeat this definition of calorie when we talk about digestive system. So it says that the estimation here, approximately only 0.5 calorie to raise 1 degree Celsius in other liquids, in other covalently bonded liquids. Therefore, we said that water has a very high heat capacity in compared to other liquid. And one more important property is that solid ice is less dense than liquid water. Most substances, they are like this. Solid is the most dense. You can look at it here. Solid is the most dense. Liquid is less dense, but gas is the least dense. That means the least closely packed. But water is different. Water is very strange. So water, same as other things, water vapor is least dense. Water liquid is more dense, but ice is actually less dense. The reason is that when water becomes ice, they form this we call it lattice structure, because they have to orient themselves. The slightly positive oxygen atom has to be aligned with the slightly negative hydrogen atom from another molecule. And because of that, they form this hexagonal lattice. The hexagonal lattice actually gives them a lot of empty space inside. The empty space inside causes the density of ice become less than the density of water liquid. Therefore, when we put ice in water, ice always flow on top. So you may ask, how come? What's the advantage? What's the significance of this? We are learning biology. The reason of this is that, that causes water less dense than liquid. So when we start to freeze water, as you can see the temperature here, as the temperature decreases, that means we are going from right to left. As the temperature decreases, you can see that the density of water increases, because just like other substances, as we decrease the temperature, then the water molecule, they become closer and closer to each other. When they become closer to each other, the density becomes higher and higher. But at around the freezing point of water, the density suddenly drop. So at around the freezing point from 0 to 4 degrees Celsius, the density suddenly drop and stay at 0.9 gram per centimeter cube. Because when they form ice lattice, as I told you that the hexagonal lattice, then the ice stabilize at that point, the structure of the ice stabilize at that point, and then the density becomes a lot lower than liquid.